rule of rules? Or even worse, if chemistry were the type of subject for which there were no rules at all? Yep, then it would be difficult. Because you'd have to sit and memorize every single list of numbers, or you'd have to memorize every single different rule for each day. And if the subject were like that, then I'd say that's what we'd have to do, and that's a difficult task, and that would make for a difficult course. But chemistry isn't difficult. Chemistry is very simple. Now, don't get me wrong. If you're taking advanced physical chemistry in college, in my opinion, that's not simple. But introductory high school chemistry is simple. It's the easiest course in school. And I really mean that. And I hope I can show you why I think that's true. Ladies and gentlemen, the reason so many students have so much trouble in what really is a simple subject is because they see every single problem in the course as being completely separate and unrelated to what they talked about yesterday or last week or whatever. The worst thing is that they try to memorize everything, like trying to memorize all the different sets of numbers. The somewhat more astute student tries to learn the rules, and that's better. But the problem is that they see every different problem as involving a new set of rules. And boy, that's difficult. I mean, they try to remember a rule on Monday for solving one kind of problem, and a different rule on Tuesday for a different problem, and then Wednesday a new rule, etc. And by the 6th or 7th week of the course, you're so burdened down by rules that you no longer can keep it all straight. Well, there's no need to memorize lists of numbers, so to speak, in chemistry. And there's not even a need to memorize a different rule for each different kind of problem, because in chemistry, everything ties together in a beautiful, simple, elegant way. And you are absolutely, positively more than smart enough to do well in high school chemistry. I'd like to use one more example to illustrate what I've said. Many years ago, I was sitting in a college course. I still remember it like it was yesterday. The professor told us that he was going to put a list of words on the blackboard. He said, "I'd like you to look at this list and see if you can figure out how the words are related. We're now going to present this list to you on a graphic. See if you can find the relationship between these words. The list looks like this." I looked at that list. I saw absolutely no relationship between those words, nor did anybody else in the class. But after a few minutes, a few students started to laugh. It was obvious that they had seen something that I hadn't. As a few more minutes passed, more students began to laugh until I think about 2/3 of the class was hilariously laughing. I'm a bit embarrassed to say I wasn't one of them. Try as I might, the relationship between those words escaped me. I saw nothing except what appeared to be a random series of words. But then the professor read the list to us like this. "Force Corin heaven yeasts ago, our force feathers brat horse upon cis continent, a new nation." The professor then erased the board. I never copied down that list. Yet after all these years, I can still recreate this list from memory. And the reason I can do that is obvious. I understand, and that makes it simple. I understand, and that makes it simple. And what I'm going to attempt to show you is the absolutely beautiful, outrageously simple logic that underlies the vast majority of chemistry problems that you might ever be asked to solve in a first-year high school chemistry course. I won't even have to teach you this logic. Let me repeat that. I won't even have to teach you this logic. You very likely use that logic almost every day of your life, and you use it simply, and you use it naturally. All we need to do is refine and expand your ability to use this logic, the logic that you use so naturally, and in addition make you much more sensitive to what you're really doing when you solve everyday problems. Because you probably never really sat down and thought about how you think. I truly believe that chemistry is the easiest class in school. Now, I am not naive. I know that most students do not share this view. If you ask the average incoming high school chemistry student, do you believe that chemistry is an easy course or a difficult course? Probably 90% will say it's difficult. I mean, obviously it's a difficult course. That's what they're going to tell you. And unfortunately, I think that for a lot of students that becomes a self-fulfilling prophecy. A self-fulfilling prophecy, in case you're not aware, is a prophecy that comes true. I mean, it literally happens and becomes true simply because people believe it's going to come true. The classic example is probably a run on a bank that actually is very sound financially. Despite being financially sound, the bank goes out of business for no other reason than people think it's going to go out of business. They panic and they withdraw their money. And I'm afraid that many chemistry students believe, an all too common belief, that chemistry is difficult. Chemistry is difficult, so I'm not going to do well in it, becomes a self-fulfilling prophecy. What happens is that students become so negative in their attitudes and so nervous if they encounter any little difficulty that they begin to block out what really is very, very simple. Think of something you're good at. I mean, maybe you're a good baseball player. Maybe that's what you excel at. When you started to play baseball, did you do everything right the first time? I mean, when you were 5 years old and your father threw you the baseball, did you hit a home run the first time? I doubt it. You whiffed and you missed and you did things incorrectly. But you believed that someday you were going to be a good baseball player. And you liked baseball. And so the inevitable small failures didn't frustrate you. In fact, they became challenges. And you became a good baseball player. In a similar manner, you are a good chemistry student. Believe that, and there's a very good chance it will happen. And I'm going to show you how it can happen. Now, some of you may be thinking, yeah, well, you can say that, but I don't believe it. And that's good. Because if you believe it just because I say it, you wouldn't be much of a scientist. You have to be critical. I don't expect you to accept something just because I say it. I'm going to show you why I think that's true, and I'm going to show you right now. I'm going to give you a problem. Now, when I say this, please don't read anything into it. I mean, students are always assuming that the teacher is going to try and trick them, that this will be a trick problem. There's no trick here. Just listen to the problem and work it. There are 3,000 students in a high school. There are 30 students per room. How many rooms are there in the high school? Now, I strongly suspect that you got 100 rooms. In fact, when I give this problem to my students, everyone always gets 100 rooms. If you solve that problem correctly, relax. You are absolutely, positively, unequivocally more than smart enough to do well in high school chemistry, and I really mean that. And the reason I say that is because most, I mean not all, but most of the problems that you are ever going to be asked to solve in high school chemistry involve exactly the same kind of logic that you use when you solve this problem. 3,000 students divided by 30 students per room equals 100 rooms. Notice that I said that the logic involved in solving chemistry problems is exactly the same as the logic you use to solve this problem. Notice I didn't hedge that statement. I didn't say, well, it's kind of like, or similar to, or sort of like. I said exactly. The logic you use to solve many, if not most, first-year high school chemistry problems is exactly the same as the logic you use to solve that problem. And if you can solve that problem, you can solve chemistry problems. Now, you might say, oh, yeah, sure, you can say that, but I can solve that problem, but I can't seem to solve a lot of the chemistry problems that I'm asked to solve. Now, why might that be the case? There's several reasons. Number one, in many chemistry problems, the numbers aren't nice. I mean, like 3,030. We get things like 58.5 grams per mole and 8.73 moles. And sometimes you have big exponential numbers like 6.02 times 10 to the 23rd, etc. And sometimes it's more difficult to reason with decimals and fractions and exponential numbers than it is to reason with nice even numbers. But the logic is the same, and we'll work at that. The more significant reason why chemistry problems prove to be difficult for many students is that they really don't know what the numbers mean. You know what 3,000 students means. You can close your eyes and visualize something like 30 students per room. But when a problem talks about 9.23 grams and 58.5 grams per mole, it blurs over. It has no meaning. And without meaning, you don't know what to do with these numbers. I'd like again to give you a feeling for what happens to many chemistry students with a little metaphor. You're on a plane and you're flying over a deep, dense jungle. The jungle obviously is chemistry. The plane develops engine trouble and it crashes. Everyone on the plane is killed except you, who emerge miraculously unhurt, and your native guide, who unfortunately has suffered severe injuries and clearly will only survive for a few more days. The native guide wants you to be able to survive in this totally alien environment. So he begins to show you what fruits are edible and which are poisonous. He points out a tree that has green fruit. Now you can eat this fruit. Green fruit is edible because, and now he explains why. He talks about the leaves and the types of branches, etc. You don't quite follow that immediately, so you figure, why do I have to know all that? I mean, I just have to remember I can eat the green fruit. And you survive that first day very nicely. The next day he points out a tree that has red fruit. You can eat this fruit too. He starts to explain about the leaves and the branches and the bark and the roots and the similarities with the tree with the green fruit. But you don't immediately follow. And anyway, I mean, who cares? You just eat the green fruit and the red fruit and you're going to be fine. The next day he points out a tree with purple fruit. He says, don't eat that. It's poisonous. And the reason is, and he starts to explain, but you don't listen anymore. You figure, I eat the green, I eat the red, I don't eat the purple. Hey, I'm going to survive. The next day he dies. You do quite well for a while. You eat the green fruit, you eat the red fruit, you're surviving beautifully. But after a while, you run out of green and red fruit. Now you don't know what to do. I mean, you can't eat the purple fruit. Starvation eventually gets the better of you. You try to remember, what was he trying to explain to me? But you never took the time or made the effort to understand. You just memorized a few things, hoping that would be enough to survive. You spot a tree with orange fruit. He never talked about that, and you didn't bother to understand what really made one fruit edible and another poisonous. Out of desperation, you eat the orange fruit. Unfortunately, it's poisonous, and you die. And that's similar to what happens in chemistry. Students may not immediately understand, so they say, I know what he did. He just takes the little number and he divides it by the big number, and that's how you solve this problem. That's good enough. I'll survive. And you do. Or you learn a particular method of solving a particular problem, and you survive for a while. But as the problems pile up, as the rules pile up, it's just like we talked about with the numbers. You've never learned the rule of rules. And now there are just too many seemingly unrelated rules to know. So you get lost and maybe even fail. At best, it's a very difficult struggle just to keep your head above water, so to speak. Well, I'm not going to let you fail, or at least I'm going to do my best to keep you from failing. I'm going to do my very best to not allow you to learn by rote memory. It's foolish to try and learn that way, and it is completely unnecessary. I'd like to make a few comments in closing. It concerns how to go about viewing these lectures. I would strongly suggest that you view the first 4 lectures in order, because they set the groundwork for the type of reasoning that we are going to do throughout the entire course. So please watch those in order and be sure you master those before you go on. After that, you may want to jump around. I mean, if your teacher's talking about percent composition, then you will probably want to watch the lecture on that particular topic because, quote, that test is coming up next Tuesday. Or if you're doing empirical formula problems or mole problems or stoichiometry problems or limiting reactant problems, you may want to watch those lectures. But if in watching a later lecture you realize that there's something going on that you don't quite understand but was clearly covered in an earlier lecture, go back and view the earlier lecture. The most critical thing, in fact, if you're not going to do this, there's little point in watching the lectures. The most critical thing is that you must try every problem. I mean, don't watch me solve these problems. I know how to solve them. You have to solve them. The learning occurs here, not on the video. When a problem is presented to you, pause the video, work at that problem for as long as necessary. Only when you A, believe that you have solved the problem, or B, hit a stone wall that you cannot go through, should you view the solution. And then I would suggest that the next day or 2 or 3 days later, you come back and try that problem again. At all times, you must be an active participant in the problem solving, not a passive observer. So let's begin our journey.